Hi everyone, my name is Kim and today I'm going to talk about Einstein's relativity. This is a simplified version. Okay, so let's get to know Einstein first. Albert Einstein is the most significant theoretical physicist during the 20th century. He developed the theory of relativity. His discovery has given rise to dramatic change the way we understand space, time, gravity, and the universe in general. So there are two types of relativity, the special and the general type of relativity. So this concept will answer some of your questions that you might have asked yourselves already. So in my case, I remember when I was a kid, I find myself asking about what would happen if I drop a coin while sitting at the edge of a speeding jeepney. So to satisfy my curiosity, I did some experiments. So I vertically dropped the coin. Then, surprisingly, the result did not go along with my hypothesis. My prediction was I would lose my coin to the ground of the freeway. Instead, what happened was the coin still landed on the jeepney floor surface. Considering my position, which was at the edge of the jeepney. So, to my mind, I was still skeptical about the result and defending my hypothesis that it happened because the jeep was not accelerating fast enough. So little did I know that what I was doing back then has something to do with relativity. Now it became clear to me after getting myself familiar with this revolutionary theory that it would never touch the surface of the freeway. This is best explained by the illustration that we have right here, which is comparable to my inquiry. So let me introduce you to my brother Carlo, who is standing on the shoreline, and I'm the one sitting on the top of the boat. So from my perspective, the telescope which I accidentally dropped falls horizontally to the surface of the boat. But my brother would have a completely different observation. On his perspective, the telescope descends to the ground in a curved path like a half of a parabola that opens up downward. So suffice it to say that both observations are true with a reputation that specifies from which point of reference. Now, let us discuss some of relativity's postulate about motion. So, for instance, taking it on a massive scale, planets move around the sun and sun moves around the galaxy. And this is same for electrons that rotate around the nucleus of an atom, and the tiny atom is in constant motion in the matter particles. Therefore, there is no such thing as absolute motion and absolute rest because things just move relative to each other. Another fact about relativity is that light is the only constant, meaning to say it is the same for both observers whether the observer is in motion or at rest. One of the components of special theory of relativity has something to do with time as well, which states that time is relative. These then would bring us to the concept of time dilation. Say for example, let's get back to my twin brother Carlo. Carlo and myself as an example. As you would have noticed, this is me on the left side, turned out, so I turned out to be a space traveler. I was tasked to go to outer space using a spacecraft that travels as fast as 80% of the speed of light. The duration of my journey to get the job done in outer space is 5 years relative to the Earth. Then, finally, the time has come to see my brother. So after 5 years, we'll get to see each other again. How different do you think we would look like? Any guess? Well, after 5 years, this is how different we will be. Well, isn't it surprising? This picture right here is an approximation of how we would look like. I barely age compared to my twin brother Carlo because as you travel close to the speed of light, your time takes slower. It's not just about my clock, but everything that surrounds me, including my thoughts, pulse rate, and even my aging process. Since I already know how will I appear in the future, and I'm not happy about it because as you can see, I'm way better looking in the present than in the future. So what should I do to retain my youth? Einstein postulated that if you are traveling with the same speed of light, your time stops. Thus, it will stop the process of aging as well. But since humans haven't come up with such discovery, it's it's impossible for now, so I don't have any choice. So unfortunately, I don't have any choice but to look like Brad Pitt when I grew older. Hence, going back to the past, or what we call time travel, might be possible in the future if there will ever be an invention, say a vessel that drifts faster than the speed of light. Let me tell you some of my experience during my journey to the outer space. When we increase the speed at 1c, that's the speed of light, to avoid some black holes, this is me inside the spacecraft facing the mirror. You might be asking why there's no reflection in the spacecraft facing the mirror. Okay, so in order, let's answer this. Let's provide some very simple explanation why that is. In order for a mirror to produce an image or reflection, the light ray should bounce to the surface of the mirror. Okay, so well, in our case, the light ray will not reach the surface of the mirror because both element, which is the light ray and the mirror, are moving at the same speed at 1c in the same direction. Another concept of general relativity is what we know as length contraction. So in a nutshell, the speed of light has an inverse relationship with length. Thus, as we increase the speed, the thinner as we increase the speed of light, the shorter and thinner a certain object would appear. But mind you that the changes in terms of height and mass is something that you would not notice or you wouldn't observe at all. So to better explain this strange phenomenon, well, it's a given fact that you can't tell if the object is moving or not with a plain background or without any reference. Another way of explanation is, say one day you wake up, then everything around you gets bigger and wider. It would be impossible for you to notice those changes because all the indication mark or reference got bigger as well. So lastly, when we're talking about relativity, this presentation will not be complete without discussing the revolutionary formula, which is E is equal to mc squared. And this is the relativity equation, which means energy is equal to mass multiplied by the speed of light squared. Who would ever thought that mass and energy are same stuff? Because these formula go against Newtonian physics that mass and energy are two different things. The formula may seem very simple, but leads us to some complex discoveries. This equation entails us that to form a small amount of mass, huge amount of energy is needed. So in conclusion, Einstein postulated that there's an evident fundamental link that exists between the two types of substance. Thus, energy can be turned into matter and matter can be turned into energy. It fortified the theory of Big Bang that could be the answer to the biggest question about the origin of the universe. So imagine how much energy would it need to produce a mass as big as our planet. So how do we know that what we're talking about, or this relativity theory, is not an illusion? Because relativity seems very counterintuitive. It leaves you a question that how can we be so ignorant about the things that we're extremely familiar about, like time, weight, height, and this is when intrinsic become non-intrinsic. Well, we can conclude that relativity concept is true because we're utilizing its principle with the use of modern GPS. It's one of the most tangible applications of relativity. The synchronization of the satellites around the Earth helps millions of people from around the world. And with this navigational tool, you would easily figure out where to go, even to some places you have not been. And lastly, the theory of relativity expanded not only in the realm of science but also in philosophy. It revolutionized our way of thinking about truth. Relativity became the inspiration of influential postmodernism philosophers, or better known as relativistic philosophers. They imparted the non-existence of absolute truth, the validity of knowledge, claim morality, and aesthetic